This is problem 4 from Son of Two-Dimensional Motion. You guys want me to work out problem 4? I think you do.
Yes, please.
Here we go. So it's 34 meters per second, 37 degrees. Right. So what's the first thing you do if they give you angle magnitude? Yeah, find the components of it. So making sure that you are in degrees, right? It's sad to take this test and be in radians. So, yeah, try to remind yourself, remind me to remind people. This is in degrees, right? So then this side here, this component here is 34 cos 37. This side here is 34 sine 37. So 34 cos 37. And this is 27.154. And then that side is 34 sine 37. And this side is 20.462. Okay, what's the next thing? Shh, class. Do we have sound? Oh, we do have sound. This is good. So it says, what is the initial velocity vector in vector component notation? Well, it's 27.1 meters per second x plus 20.5 meters per second y. Why? Why? Because I love you. What time is the projectile in the air? What's its range? What's the speed at the highest point? All these things, right? So these things go in. And if we go from the launch to the ground, what's the trick from going to the launch to the ground? What's our trick?
From launch to the ground?
Yeah. Where do we put these guys? And how do we do it?
That's the vertical. 20.
That's our vertical initial, right? 20.462. And that's the 27.15 is our horizontal, right? 27.154, 27.154. So those are, it doesn't change because this guy's 0. This guy's negative 9.8, right? And then what's our final here? What's the trick? It's negative that because it's going to go up and come down, right? This guy's 0. It's like we almost have, we don't have the time, but we almost do, right? Okay. So I'm going to take that and divide it by, so my favorite formula is VF equals VI plus AT, would get the time. And it's in the air 4.1758 seconds, right? That time goes across 758. It's actually 5.9, but anyway. Okay. And then to find how far it goes, we're going to multiply this guy by this guy. So that times 113.4. Is that the answer I got? Yeah, 113 meters. Right? So we've answered what time is it in the air. We've answered what its range is. The range is just the horizontal distance, right? And then how do you figure out the speed at the highest point? Well, at the highest point, what's it going to be doing? It's going to go like this. It's going to be like, it's going to have only horizontal velocity, right? So one of these guys is the speed at the highest point, right? It's going to be going 27.154 at the highest point, just to the side. And that is the speed. Yeah? So that's a tricky thing, right? And then it says, what is the velocity of the projectile in vector component notation when it's on the way up at an elevation of 10 meters? Oh, good golly. How can we do that? Well, we need to re-Suvot it, right? I guess I need to erase this. Go a little wide on that. So on the way up at an elevation of 10 meters, so on the way up at an elevation of 10 meters, what do we know? We have to re-suvat, or set up our thing. What do we do? What do we know? Same time? No, I don't think so, because it's going to be like less than that. Because it's like here. We're going to catch the thing right there on the way up. Right. We know the what? Where do we put 10 meters elevation? Vertical. There we go. This is definitely going to be plus 10 meters. Then when it says on the way up, how are we going to distinguish? Where does that make a difference? On the way up, it's going to have a positive velocity, yes? And on the way down, a negative at 10 meters. That'll be the difference, right? What else do we know? Can we use the same launch components? Can we? I think so, right? So this guy is going to be 27.154. It will always have a velocity of 27.154 because it just doesn't accelerate horizontally, right? How about our initial vertical? We can use that, right? 20.462. This is negative 9.8. Is our final at 10 meters, is that going to be the same? Is it going to be negative? Is it at the top? Is 10 meters the top? Are you sure? No, not so sure. Okay. But we are sure of 10 meters, right? It might be the top, but we are sure of 10 meters. We already have three things here. So it seems like we ought to be able to figure out these things from that, right? Okay. So what do they want to know? They just want to know the velocity when it's on the way up. What's its speed, right? So all we need really is this. Yeah? So how do we find the final velocity there? That's the one, yeah. Vf squared equals Vi squared. Right? So Vf squared is 20.462 squared plus 2 times. Yeah? Okay, there we go. 14.922. So what's its speed? This is its velocity, and I think that's right, isn't it? Yeah, 27.1, 14.9. What's its speed? It says what this is. So velocity in vector component notation is 27.1 meters per second x plus 14.9 meters per second y. How would you figure out the speed of that? The hypotenuse. So draw a picture of it like this, right? 27.154 plus 14.923. So that squared plus 27.154 squared, square root of that. It's a little crazy that this squared plus this squared is exactly 960. This is 30.983 whatever, 31 roughly. Is that what it is? Yeah.